Hello there, hello all. Welcome to Learn with Mr. Tamuli. If you are keen to learn, you have found the right tutor. That's me, Mr. Tamuli. Be assured, you will be able to learn thoroughly with Mr. Tamuli. This tutorial will be presented by Ms. Benita. Let me tell you that Ms. Benita is a sharp lady. I am sure you will find Benita's presentation very absorbing.
Hello friends, my name is Benita. Actually, I am a virtual assistant of Mr. Tamuli. I shall present this tutorial on behalf of Mr. Tamuli. In this series of tutorials, you have been learning 6th standard mathematics. The current series of tutorials is for the first chapter of your textbook. The name of the chapter is Knowing Our Numbers. This tutorial is the tutorial number 6 for the first chapter. In the earlier tutorials of this series, you learned the fundamentals of writing and naming numbers. In this tutorial we shall solve some practice examples, and in the process get ourselves introduced to whole numbers. So, without further ado, let's start the tutorial. The first example problem that we shall solve is, prove that 999 is the largest 3-digit number. Some of you might feel angered to see a silly question like this. You might feel that everyone knows for a fact that 999 is the largest 3-digit number. There is no need to prove a simple fact like this one. As a solution to this example problem, you may be tempted to write, since in all the three positions of the 3-digit number 999, we have the largest digit 9. Therefore it is obvious that 999 is the largest 3-digit number. This can be considered as a very good answer. But it can't be considered as a solution to the problem. In mathematics, the truth or falsity of a statement needs to be proved beyond doubt or unquestionably using logical and mathematical methods. The solution of this problem goes like this. The given 3-digit number in the example problem is 999. So first we shall write, given number is equal to 999. We know that the number which immediately succeeds 999 can be found out by adding 1 with 999. So we write, immediate successor is equal to 999 plus 1. Which is equal to 1000. Here, you need to carefully observe two important facts. The first fact is that 1000 is the number that immediately succeeds 999. The second important fact is that 1000 is a 4-digit number. Since the number that comes immediately after 999 is a 4-digit number, therefore 999 must be the largest 3-digit number. So in our solution we shall simply write, since 1000 is a 4-digit number, therefore 999 is the largest 3-digit number. The first three triangular dots, with the tip pointing downwards, that you can see here is the mathematical representation of the word since. The other three triangular dots, with the tip pointing upwards, is the mathematical symbol of the word therefore. So you have seen that we proved the statement, 999 is the largest 3-digit number, using logical thinking and a simple mathematical operation of addition. If you have somehow found the method of solution to this example problem a little difficult to follow, applying the same method to smaller numbers will help clarify your doubts. For instance, let's take the number 8. What is the number that immediately succeeds 8? We all know that 9 is the number that immediately succeeds 8. And how do we get 9? We get 9 when we add 1 with 8. Similarly we get 10 when we add 1 with 9. So the immediate successor of 9 is 10. And 10 is a 2-digit number. There is no single-digit number after 9. So 9 is the largest single-digit number. In the same manner 99 is the largest 2-digit number. Just a little while ago we proved that 999 is the largest three-digit number. Similarly, 9999 is the largest four-digit number, and 99,999 is the largest five-digit number. And so on. Please pay attention to the fact that these largest numbers are made up of the digit 9, which is the largest among the decimal digits. Again, if you carefully look at the consecutive numbers 8, 9, and 10, you will also be able to figure out the fact that 10 is the smallest two-digit number. Because the number that immediately precedes 10 is a single-digit number, which is 9. Similarly, when you look at the consecutive numbers 98, 99, and 100, you find that 100 is the smallest three-digit number. Because the number that immediately precedes 100 is a two-digit number, which is 99. With what we have learned so far, I hope you will find the next example problem easy to understand. Prove that 1000 is the smallest four-digit number. The solution of the problem goes like this. Given number is equal to 1000. This time we are interested in finding the number that immediately precedes 1000, which we can find by subtracting 1 from 1000. So we write, immediate predecessor is equal to 1000 minus 1. Subtracting 1 from 1000, we get 999. Since 999 is a three-digit number, therefore we can conclude that 1000 is the smallest four-digit number. Previously we learned that 10 and 100 are the smallest two-digit and three-digit numbers respectively. Now we know that 1000 is the smallest four-digit number. Similarly, 10,000 is the smallest five-digit number, 1 lakh is the smallest six-digit number, and so on. You should pay attention to the fact that these smallest numbers are composed of mostly zeros and ones. 0 and 1 are the smallest amongst the decimal digits. In tutorial number 4 we had learned another important fact about these smallest numbers, which is, the smallest six-digit number 1 lakh is the place value of the sixth position. The smallest five-digit number 10,000 is the place value of the fifth position. The smallest four-digit number 1000 is the place value of the fourth position. The smallest three-digit number 100 is the place value of the third position. The smallest two-digit number 10 is the place value of the second position. We know that 1 is the place value of the first position. But, is the number 1 also the smallest one-digit number? We have thus landed upon a somewhat confusing but very important question. The question is, what is the smallest single-digit number? Is it 1, or is it 0? The most obvious answer to this question is 0. Because 0 is smaller than 1 and it is also a single-digit number. But there is a problem in calling 0 the smallest single-digit number. If I call 0 the smallest single-digit number, some of you might like to logically conclude that the smallest two-digit number should be 00, and the smallest three-digit number should be 000, and so on. And I must confess that it's not a bad argument at all. But just a little while ago we conclusively proved that the smallest two-digit number is 10, the smallest three-digit number is 100, and so on. So we find that calling 0 the smallest single-digit number creates a bit of a confusion, or it leads to a contradiction of some sort. And in mathematics, we always want to avoid contradictions. We must find a way to remove this contradiction. To do so, we need to understand the fact that there is something about the number 0 which is not quite as natural as the numbers larger than 0. When I say, there are 5 apples on the plate, or when I say, there are 50 tennis balls in the box, it sounds perfectly natural about the count of the apples or the tennis balls. But if I say, there are 0 tennis balls in the carton, or if I say, there are 0 apples on the plate, it doesn't sound perfectly natural. The perfectly natural words would be to say, the plate is empty, or the carton is empty. The point I am trying to make here is that the number 0 is not a natural number, or alternatively it can be said that the number 0 is not a counting number. Please be mindful of the fact that here I am talking about the number 0, not about the digit 0. Our ancestors started using numerals for counting, probably a couple of thousand years ago. It is obvious that, to count objects, they started with the number 1, and proceeded gradually towards larger numbers. It is not natural to count objects starting from the number 0. Our ancestors invented the digit 0, primarily to use it as a placeholder digit, which greatly enhanced the technique of writing numbers. You would remember that we discussed the concept of 0 as a placeholder in our tutorial number 2. From being just a placeholder digit, 0 got the distinction of being the number that precedes the number 1, at a much later stage. I think we have now enough background to remove the contradiction that arises out of calling 0 the smallest single-digit number. We now know for sure that the number 0 is not a natural number, or it is not a counting number. In mathematics we call the numbers starting from the number 1 onwards, the natural numbers or the counting numbers. So when we are talking about natural or counting numbers, the smallest single-digit number is the number 1, not 0. Because 0 is not a natural number. Even though we have now convinced ourselves that 1 is the smallest single-digit natural number, somehow we still feel in our heart that calling 0 the smallest single-digit number makes a lot of sense. In order to keep 0's distinction of being the smallest single-digit number intact, mathematicians came up with a trick. The trick is to define a new collection of numbers starting with the number 0 as the smallest, and continuing through 1 2 3 onwards. Mathematicians decided to call this new collection of numbers as the whole numbers. Of course, there are other reasons as well behind defining this new collection of numbers called whole numbers. We shall learn about this in subsequent tutorials, covering Chapter 2 of your textbook. For now it is sufficient to know that the collection of natural or counting numbers begins with the number 1, and move onward through 2 3 4 5 etc. The collection of natural or counting numbers excludes the number 0. On the other hand, the collection of whole numbers begins with the number 0, and moves onward through 1 2 3 4 5 6 etc. So, in mathematics, the numbers 1 2 3 4 5 6 etc. are natural numbers as well as whole numbers. Yes, you heard it right. The numbers starting with the number 1, and proceeding through 2 3 4 5 6 etc. are natural numbers as well as whole numbers. But the number 0 is only a whole number. It does not have a membership in the collection of natural or counting numbers. It brings us to the conclusion that when we are talking about natural numbers, the smallest single-digit number is the number 1. And when we are talking about whole numbers, the smallest single-digit number is the number 0. This way the mathematicians made it possible to keep alive our feeling of wanting to call 0 the smallest. I feel we have now gained enough knowledge about numbers to be able to solve the questions from the exercise 1.1 for the first chapter, Knowing Our Numbers, of your textbook. We shall solve some of these questions from the exercise 1.1 in the tutorial number 6.a. See you soon in the next tutorial class.